What's S and P? First of all, let's say that we have a polynomial. The basic form of polynomial is ax squared plus b times x plus c. And if this is equal to 0, its roots are going to be x1 and x2. So s is the sum of the roots, so x1 plus x2. P is the product of the roots, so x1 times x2. Now, we can write up a polynomial, a second degree polynomial, like a times x minus the first root times x minus the second root. Now, let's expand this form. It's a times x squared minus x times x1 minus x times x2 plus x1 times x2. Okay, let's simplify it. It's going to become a times x squared minus x1 plus x2 times x plus x1 times x2. So do we see anything in common? Yes, this is p and this is s. So we can write it up like a times x squared minus s times x plus p. Okay, so what does this equal to? So this, or equation a times x squared minus s times x plus p, this, it is equal to this form of the polynomial. So let's write it up. We're gonna divide both sides by a. So in other words, multiply it by 1 over a. So now, what do we see? We see that for this to be equal, this coefficient has to be equal to this coefficient, and this has to be equal to this. So we can write it up like negative s is equal to b over a, and p is equal to c over a. Well, we just got the formula for p. Now let's get it for s. This is simply going to be, if we multiply both sides by -1, the result is going to be s equals negative b over a. So now we got both formulas. But now here is the question. If you got x1 squared plus x2 squared, what is that going to be in terms of s and p? We can start based of the idea that x1 plus x2 squared has both x1 squared and x2 squared. So let's see what that will be. Okay, now that we see what it is, what do we see? That we only have to move the 2x1 times x2 to the other side of the equation, to the left side of the equation. And we will have x1 plus x2 squared. And this is technically 2p. So it can be written up like 2p. So minus 2p is equal to x1 squared plus x2 squared. And what is x1 plus x2? Well, it's really just f. In the end, we got that x1 squared plus x2 squared is equal to s squared minus 2p. What happens if you try to calculate x1 to the third power plus x2 to the third power? Well, we can use the same idea, so I will write it up. Okay, I've used the Pascal's triangle here. I will make a video on that. It's really good, it's really useful when you're working with polynomials. Well, this is really just s to the third power and is equal to x1 to the third power plus x2 to the third power plus 3x1 x2 times x1 plus x2, because they have 3x1 times x2 in common. Now this is really just p and this is s. So if we bring that over to the left side, I'm gonna switch the sides because it's an equality, so you can do that. It's an equation, there's equal sign. So it's going to be x1 to the third power plus x2 to the third power. It's going to be equal to s to the third power minus 3 times s times p. We've done this too. So that was the video. But don't go just yet, because we got a challenge for you. Try to find the formula in terms of s and p for x1 to the fourth power plus x2 to the fourth power. Thank you for watching. See you in the next video.